right, let's walk through these. First one can be done how? Someone tell me a method for finding the first limit. There's a couple. L'Hopital is a great method. Is there another one we've learned recently? Comparable growth rates, right? So, log always loses. Log is the loser, LL, right? Okay, log always loses. Log is the slowest. So you have a logarithmic over a polynomial, slower over faster. What's this limit going to approach?
0.
0. Next one. Limit as n approaches infinity of x to the 1 over n. So if n approaches infinity, what does the exponent approach? 0. So you end up with x approaching 0, which equals 1. It only equals 1 if your x is positive. If x is negative, it's all messed up, right? So we're just talking about the positive values of x for that one. But yeah, it's 1. All right, I'm going to jump down to number 6. Tell me a method that you could use for number 6. Comparable growth rates, right? Because L'Hopital doesn't work for 6. Why can't you L'Hopital 6?
It's not something else.
It is something over something, and it is infinity over infinity. But you're okay, that's okay.
I was thinking of it.
Tell me where you would get stuck if you were L'Hopital in 6.
Factorial.
Factorials don't have a derivative, right? They're not continuous functions. So you can't differentiate a factorial, but you can do comparable growth rates. The factorial, oh wow, factorial is the fastest. Wow, right? Logarithms are the losers, factorials are the fastest. Oh, look at that, right? Okay, so anyway, yeah, so this thing is going to 0. All right, any other quick ones? 5. Did anyone get a quick answer for 5? It's okay, shout it out, don't be afraid. Infinity, right? Did anyone else get infinity? No? Yeah? Okay, that is a correct answer if your x is what? Greater than 1. But if your x is, as we were just talking about with geometric series, if your x is between -1 and 1, that limit's actually going to go to 0. So what we end up with is 0 for an absolute value of x less than 1. And we get infinity for any x's that are bigger than 1. If x is a negative that's less than -1, right, where the absolute value is bigger than 1, but it's negative, then it just gets all messed up. Right, so, yeah. These last two are tricky. 4 is what? 1? Very good. Did you get that just by kind of thinking about it, or?
The square is 1 over n. I mean, 1
n to the 1 over nth power?
Yeah. And then when it goes to infinity, it's n to the...
n to the 0, which is 1. Yeah, and that works. Yeah, I'll take that. It is 1. By that account, then, this one's tricky. 1 plus x over infinity to the infinity of power. That's one of those tricky ones, right? We know 1 plus 1 over n to the nth power, if we took the limit, that is not 1, is it? Right? Yeah. So let's try this one, just for fun, right? And just see what happens. It is a complicated limit. I'm going to have to write small and just see if we can squish it in here. Maybe I'll do it down below. So we have 3. So the way, remember when you plug in, you get 1 to the infinity, which means you're going to have to use logs to solve. So you set equal to y, take the log of both sides, so you get the limit as n approaches infinity of n ln 1 plus x over n. Putting the exponent in front of the log. Okay, so what we get here is infinity times 0, so we have to write it as a quotient. So now we get 0 over 0, we can L'Hopital. L'Hopital is tricky on this one. Because you have to think of x not as a variable, but a constant. N is really kind of your variable for this. X is more like an unknown constant. So when you take the derivative natural log of 1 plus x over n, so the bottom is 1 plus x over n, the derivative of this, that's 0. The derivative of x over n is the same as if you think of it as x n to the negative first, you get negative x over n squared. And then this whole thing is over the derivative of 1 over n, which is negative 1 over n squared. All right, so we get this whole thing. Isn't that fun, right? Don't you love these triple, quadruple compound fractions, right? Complex fractions? Okay, so, yeah. So let's see how to clean this up. I'm going to move over here. A little sideways stuff. So we have x, I wonder if I multiplied everything, let's just go ahead and do it like this. So we have negative x over n squared over, I'm going to write this as n plus x over n, times negative n squared over 1. All right, and if you want to clean this up first, if you're confused about how to flip the fractions around and everything, you can feel free to clean this up first. So this actually equals, if I multiply top and bottom by n squared, so I get negative xn over n times n plus x, all times negative n squared. All right, so this is fun. So we cancel an n, cancel an n, we can cancel the negatives, and we end up with the limit as n approaches infinity of positive xn squared over x plus n. This is wrong, I made a mistake
I
somewhere.
think when you went from just at the bottom one, you have, when you multiply by n squared, you had the top as negative xn, when it should
Oh, it
just
should be just
x.
negative x, thank you. Thank you. So this is just x, I knew it was going to go away. Okay, because I know what the answer is. It's always easier to do problem when you have the answers. All right, so limit as n approaches infinity. So we have, I don't know why I'm writing it because I'm done. So as n approaches infinity, remember this is really just kind of a linear over a linear. If you want a L'Hopital, the n's will just go away and you're left with x over 1. So what we have is ln y equals x. So y is e to the x. Okay, did y'all do that?
No.
And if I am seeing a pattern here, and I'm going to go ahead and go on tape and say I'm not positive about this because I haven't checked it. It would only take a minute to check, but I just haven't yet. But I know that 1 plus 1 over n to the n is e. So I'm thinking if I had like 1 plus 10 over n to the n, it would be e to the 10th. 1 plus 20 over n to the n would be e to the 20th, right? 1 plus x over n to the nth is e to the x. That's my thinking. So kind of thinking about if I were to rerun this with, you know what, it's not a guess, it's a definite. Because x represents any unknown constant, right? So it doesn't matter if I replaced x with a 20 or a 50, I treated it like a constant in my evaluation, so of course it's just e to whatever that is. Yeah, fun with limits, good. Let's kind of use those skills a little bit and have some more fun with convergence. Now, this is not from today's lesson. This is a little backtracking to 9.1, just to see if you can remember it. So, these are not series, these are sequences, and we're just trying to decide if each of these converge or diverge. How do we know if a sequence converges? Yeah, if there's a limit, if the limit exists, right? Yeah. So all you're doing, again, it's kind of fun. You just did 6 of them. Haha, we're going to do another 8, right? Okay, so take the next 5 5-10 minutes. A lot of these you can figure out without doing any work at all. Alright. Once you get through the first couple, I will show you the answers and then I'll move it down so you can see the last one. Okay, talk amongst yourselves, make sure you run through, think about these a little bit logically. Don't just try to do them all with algebra. Try to think about them a little bit. Think about the limit as n approaches infinity of sine squared over 2 to the n. Right, and what the implications would be.
Is the first one 0, guys?
And then remember, once you find your limit, make sure you write down if it converges or diverges.
Since 2 to 3 the sign of anything isn't going to go be like
That's okay, it's all choices. I never force. If you don't want to, if you want to learn it on your own, I'm not going to force you.
Yeah, I'm going to do that tonight.
Yeah, it's all choices. If you have stuff you need to work on.
Well, yeah, because what else did it result in?
It's not really typically a polynomial, but it kind of falls in that same family of n to the power.
Yeah.
You miss integrals?
Isn't that funny?
So far, I am not minding this teacher. I just like it. When I was the first week or 2 I was planning for it, and then when I developed a comfort level, now I like it.
Like so far it's not like it's wrong.
Yeah.
I'm doing fine, it's just like, I just don't feel really
Yeah.
like,
That I haven't developed yet. You don't have a sense of purpose.
yeah, it's not like it's solved.
Right.
Like you're given
It's some convoluted situation where you're finding some convoluted made up answer, yes. And now you understand why after planning the first 10 lessons, I'm like, why are we using this, right? Because it does, it feels like made up numbers. But there is purpose. There is purpose to it. It's just that we don't see it yet. Well, sometimes there's value in learning, you know, how notes and stabs work, even if you're not going to be musicians, right?
That's true.
Yeah. Good general knowledge.
Like you do use music many times in your life.
Maybe you'll use this. You never know. If nothing else, you will use the reasoning skills.
I agree with math at early stages.
Oh, what did I hear? Mechanical engineering is the only practical application for imaginary universe. Yeah. I don't know. That's all I know. Is I had a former student who was a mechanical engineer and told me that.
Imaginary numbers were like my favorite chapter.
But what was the purpose of those?
You can't punch.
I'll have to ask my engineering friends.
But it can actually make sense. Like, because when you have a square root of a negative number, you never know what to do, and then you actually give the same. This just doesn't quite do anything.
All right then. So for the first one, sine squared n over 2 to the n. what method, Siddharth, what method did you use for number 1?
I didn't really use a method, but I realized that the sign of anything isn't gonna like be some drastically large number.
What's it always gonna be between?
I have, no. What is it? Oh, 1 and negative.
There you go. Perfect, with teamwork, right?
Yeah.
Yes, excellent.
And then 2 to the end, it can be anything, it can go up there.
Right, yes, exactly. You've got something that's always stuck, right? Technically, its sign is stuck between 1 and -1, sign squared, now we're between 0 and 1, right? So anyway, you've got something that's some little constant over something that's growing to infinity, so this thing as a whole is converging to 0. Good. Mike, how you doing?
Good, how are you?
I'm doing fine, thank you for asking. So we have natural log n over root n, which, tell me how you thought of this.
Well, I did the growth rates, and then the natural log of n is the slowest, and that's on top, so it must be 0.
Yep. Even though root n is not technically a polynomial, we kind of treat it like one. It's still like n to a constant power, so it's going to grow a little bit faster than ln. It's not going to be amazing, but it will grow faster. So this also converges to 0. Hey. All right. So does anyone have an answer for number 3? Yeah, Bethany.
I said that it diverges because up front you have a -1 to n, and as that n becomes odd and even, it will switch between -1 and 1, therefore it will converge to the default trace.
Perfect. All right, guys, I don't know if you heard what she said, but since the n's approaching infinity, this thing as a whole is just going to 1, because this term's going to 0, right? It's not to a power. It's not like e, right? It's just 1 minus 1 over n. So you just got 1 minus 0. So what you get is -1 flip-flopping right back and forth. And you can't have a limit that flip-flops like that. So you end up with a divergent series. Good. Anyone have an answer yet for number 4? No, 1 second. Elsa! Give me your thinking for number 4.
We said it was 1 because -1 to infinity is going to be -1 or 1. It's just going to be a constant and such that they can be
Right, exactly. Beautiful. Did you guys hear what she said? This -1 to the n is always just going to be some little constant that's either -1 or 1, right? So you have infinity plus or minus 1 over infinity. Infinity over infinity. And this again is kind of following the L'Hopital or the horizontal asymptote rules, where you can just think of it as like n over n, which approaches 1. Very good. Good. Anyone get to number 5 yet? Or do I need to give you 2 more minutes? How about I give you, oh, I've got the same, like 3 people that have every answer. I'm going to give you 5 more minutes to see if you can finish 5
only have 1 minute.
We only have 1 more minute?
Yeah.
Oh, okay, then let's very quickly come through. So number 5, I would do with L'Hopital. So derivative is 1 over n over 1 over n. Derivative of natural log 2n is 1 over n. So, because it's 2 over 2n, right? So you end up with converging to 1. When you do factorials, get in the habit of rewriting the factorial as n plus 1 times n factorial so that you can cancel the n factorials, right? So this thing is going to infinity, so it diverges. This one is a very clear-cut L'Hopital, converges to a half. And the very last one, the sine and cosine become insignificant and it converges to 2. Yay! All right, have a wonderful afternoon, guys. All right.
Going well.
You're studying for your test?